Hello everyone. In this video, we'll be listening to the pre-treatment called Bioscouring. The most important wet process used on textile products before dyeing or printing is scouring. What is scouring? Scouring is a cleaning or else a pre-treatment that removes natural wax and non-fibrous impurities from cotton fabric, as well as any additional soiling or dirt can also be removed. This covering can be done by alkali chemicals like sodium carbonate and sodium hydroxide. The usage of alkali on cotton fabric may result in reducing the strength of the fabric and hence the fabric gets damaged. The lifespan of the cotton fabric gets reduced. So in order to overcome the problem of getting damaged cotton fabric after scouring, people started using enzymes for scouring. So enzymatic scouring or bioscouring uh, is a process in which the application of living organisms and their components are used to remove the natural and added impurities from cotton fabric. So in this video, we'll be discussing about this enzymatic scouring or bioscouring. Why bioscouring? Since the usage of chemicals result in less fiber strength, we have shifted from chemical scouring to bioscouring. In traditional scouring process, caustic soda works on swelling method and attacks the secondary cell wall. So since the cell wall is attacked, it causes damage to the fiber and its strength as well. Again, there seems to be excessive weight loss when we go for conventional scouring with chemicals. For caustic scouring, it is 3 to 8%, but in practice, it is around 8 to 12%, which means excessive loss of fabric weight unnecessarily. The factory has to pay extra money for this unavoidable fabric loss, which cannot be accepted. Third, the need for bioscouring is dye loss. Actually, when the unnecessary particles are removed from cotton fiber, dyeing can be done very evenly without any dye loss. Without scouring, if we go for, or else without bioscouring, if you go for dyeing, there will be dye loss also. Energy and time concern. In caustic scouring, it takes around 105 degrees Celsius, and to achieve this 105 degrees Celsius, huge amount of energy is spent. And again, when the fabric has to be brought down to room temperature, several rinses are needed, which reduces the productivity or else the efficiency of productivity. So rinsing and neutralization. Again, there are many times we have to rinse neutralize when we go for caustic scouring. This is not the problem with bioscouring. And again, when caustic scouring, that effluent liquor is tested for its BOD, COD and TDS, caustic scouring is responsible for 54% of the total BOD, 49% of total COD, and 10 to 20% of the total population load generated during textile processing operation. So this scouring operation itself causes a huge damage to the environment. So there is a urgent need to be shifted to bioscouring. And the handling of harsh chemicals increase the risk of accident, and the workers are sometimes badly damaged by the harsh chemicals in use. So when we use enzymes, the problem with the risk in chemical handling is also nullified. What is the mechanism behind this bioscouring? Actually, the main agenda of scouring is removal of wax. It is the major factor which improves the wettability of the fabric too. So pectin, which is present in the uh, cotton material, it functions as a glue binding wax to the fiber. So we have to remove pectin. So this enzyme, what we use for bioscouring, will act on this pectin. So the enzyme used is pectinase, and it will act on the pectin, and it will remove pectin, so that the wax can be removed again easily. So only pectin can be removed by pectinase, and then the wax can be hydrolyzed. So if there is any calcium ion present in the water or this covering bath, it may uh, slow down the removal of pectin. So there should be a sequestering agent, or else a complexing agent, or a chelating agent, uh, which may form a complex with the Ca2 plus ion and make the Ca2 plus ion inactive, so that the process of removal of pectin is not slowed down. So 2/3 or more of the pectin must be dissolved in order to emulsify enough wax for a good wettability of dye. Without the removal of pectin in an efficient way, you cannot expect bioscouring to happen. So emulsification is strongly enhanced at temperatures above the wax melting, that is above 70 degrees Celsius. This is the mechanism of bioscouring. Thank you.